Hello, this video will discuss weathering and erosion, and we'll get into detail on mechanical weathering. This video coincides with the opengeology.org textbook that us at Salt Lake Community College have developed. So for weathering, first we'll define weathering and talk about how it's different from erosion, and then discuss the two major types of weathering, and finally get into the details of mechanical weathering. Weathering is essentially the physical and chemical breakdown of rocks near the surface. And eventually, if kept in place, these rocks become sediment, also known as soil, right? So two types of weathering are mechanical weathering, which is the physical breakdown, and chemical weathering, which is the chemical reactions that break down the rocks into smaller pieces. And the difference from weathering and erosion is that erosion implies that movement has occurred, and that's a major way that it's different from weathering. And those erosive forces can include water, ice, wind, and gravity, right? So let's talk a little bit more detail about mechanical weathering specifically. What mechanical weathering does, and it works in a team with chemical weathering, is it increases the surface area of the thing that it's acting on. So it'll break the rock down into smaller pieces. And if chemical weathering has more surface area to work with, more surfaces the chemical reactions can occur on, then you can make that chemical weathering happen more quickly. If you are just attacking the outside of one very large block, you're just affecting that surface on that large block and not any part of the inside volume. But if you break that block into much smaller pieces, that chemical weathering has much more surface area to work with. So that's how mechanical and chemical weathering can work together. So here are the few different ways that mechanical weathering can happen. One way that's common, especially here in Utah, where we have these freeze-thaw cycles, is frost wedging. So water has this amazing ability to expand when it freezes. And what will happen is water will seep down into cracks and things of that nature, fractures and fissures, and when it's warm, and then when water freezes during the winter time, when it gets colder, it'll expand and push apart that rock slowly. And when you do this repeatedly over time, you can mechanically weather and disintegrate rocks. And a similar idea, you can also grow salt crystals. You can have ions, charged atoms of dissolved in water like groundwater or ocean sea spray. And as that water evaporates or leaves the area, it can potentially precipitate or leave behind these salt crystals. And as these salt crystals grow, they can push apart the grains in the rock and physically, mechanically weather that rock over time. You can get textures like taphony, which is kind of like the Swiss cheese looking effect in this rock here. Another way you can mechanically weather rock is this pressure expansion. So believe it or not, rock has an elastic property to it. That means it can bounce back to an original shape. If you bury a rock deeply, you're compressing it. And as erosion removes stuff that's overlying that rock, you're releasing that pressure. And that pressure is released over time. The rock bounces back and can deform brittly when it's bouncing back, especially if that happens quickly. And you see this in batholiths, especially like the batholiths at Yosemite or in Little Cottonwood Canyon. You get the sheeting of rock popping off and coming off of these big plutons of granite over time. This unloading can cause this sheeting, this exfoliation. Here's a link to an actual video of somebody recording this exfoliation happening before their eyes. It's pretty amazing. Of course, biological activity plays a significant role in the breakdown, the physical breakdown of rock material via mechanical weathering. You can have plant roots wedging their way in between cracks and crevices, looking for water. And as they do so, they push apart that rock material. Another great mechanical weathering agent is burrowing animals, churning up, breaking apart, pushing apart rock material over time. And then abrasion kind of falls into this category as well. It involves erosion because there's moving sediment pushing up and grinding up against rock material. And this is how rivers, streams, and glaciers do a lot of the mechanical weathering on material. And it kind of overlaps with erosion because there's moving material involved. But here are some potholes. There's a picture of a pothole with a person for scale. This is kind of a depiction of how that pothole might form over time. And so that's it for mechanical weathering. In the next video, we'll discuss chemical weathering in more detail, and especially dissolution, karst, and a little bit on oxidation and hydrolysis. Thanks for listening, and please do subscribe if you're interested, and I hope these were helpful in teaching you some geology.